This video is for lesson 38-2 about probability of events involving and or. Learning goals are to use probability in real-world situations, to describe sample spaces again, and to find probabilities where events have and or. Do you remember this list from the previous lesson we worked on? There were 12 contestants in a contest, and we asked ourselves probability questions such as, what is the probability a person chosen at random is Casey James? Or what is the probability the person is female? Now let's try some probabilities where the events have a combination of factors. For example, number 1, what is the probability the contestant will be female and under 21? To find this, we need to know how many people in the list fit both of those criteria. So we're looking for females who are under 21. Not Crystal, because she's 24. Not Dee Dee, she's 23. We got to find only the girls that fit both criteria. So Katie works and Siobhan works. So that's 2 out of the 12 contestants, or 1/6. Now let's skip ahead to number 2 and address a probability situation where we're looking at 2 criteria but using the word or to connect those criteria. What is the probability the contestant will be female or under 21? So going back to this list, we're looking for females or contestants under 21. We can count Aaron because he's 17. We can count Crystal, she's female. We can count Dee Dee and Katie. We can count Lacey. We can count Paige, Siobhan, and Tim because he's under 21. So this time there are 1, 2, 3, 4, 5, 6, 7, 8 who qualify. The probability is 8 out of 12, or 2/3. Notice there's a higher probability for our situation that uses the word or compared to the situation that used the word and. The word and narrowed the possibilities down to fewer choices. The word or broadened the list of possibilities that qualified. Let's jump ahead to number 4 and take a look at another way to show sample spaces. In the previous lesson, we listed to show sample spaces. You might remember a situation we wrote G, G, G to represent a family having 3 girls. You can also use a table to indicate sample spaces. Kathy likes Honeycrisp cereal. Each box of Honeycrisp has a plastic animal, a monkey, elephant, caribou, or bear. And each of the 4 animals is likely to be found. Kathy's younger brother Brian prefers Corn Invaders cereal. And in that cereal there is a Hero Comic 1, a Hero Comic 2, or a Hero Comic 3, and each is likely to be found. Tomorrow Kathy's going to open a new box of the Honeycrisp, and Brian will open a new box of his favorite cereal. Find out what prizes they have. So we're asked for the sample space. Instead of making a list, for example, we could get a monkey and comic number 1, or we could get an elephant and comic number 2, and so on. You might better organize this with a table. That table could look like this. Across the top, we make columns out of the choices found in Brian's favorite cereal. And down the side, we can make rows out of the choices found in Kathy's favorite cereal. This might be a better way to organize the information. So now you can more clearly see that you can get a monkey and Hero Comic 1. Or over here, you could have the monkey and Hero Comic 2. Or you could have the monkey and Hero Comic 3, and so on. There are 12 possible combinations of the 4 toys in Kathy's cereal, along with the 3 comics in Brian's cereal. This table helps us to see that the denominator of a probability situation is 12 because there's 12 boxes in the table. What is the probability of getting the monkey and Hero Comic 1? That's this box, and so it's 1 out of 12. Now jump ahead to question 6. Let's take a look at a sample space shown with a table, but in the table it shows counts of things. A store has 48 different phones available with or without caller ID and with or without a speakerphone. The number of phones with and without the features are shown in the two-way frequency table shown below. Two-way is referring to the fact that it has columns of numbers and rows of numbers. In the first box, the 18 is representing there are 18 phones that have a speakerphone and have caller ID. This box here, the one with the 12, shows there are 12 phones that have no speakerphone and no caller ID. With a chart of information like this, you can answer all sorts of probability questions. For example, question C says, if a phone is chosen at random, what is the probability it has caller ID? That's the first row of the chart, where we're told there are 20 phones with caller ID. And so that probability is 20 out of 48. Do you see where I'm getting the 48? That's this box right here. There are 48 total phones in this situation. Or we could ask other probability questions like, what is the probability of getting a phone that has a speakerphone but no caller ID? We'll find that information. Has a speakerphone, so in the first column, but no caller ID. That's this one, the 16. And so that's 16 out of 48. So having a two-way frequency table really helps you to get probabilities figured out. Jump ahead to the Check Your Understanding questions, number 7. Students who take an AP Calculus exam can take either the AP AB exam, which is a little bit easier, or the AP BC exam, that's a little more difficult. AP tests are scored from 1 through 5, with 5 being the highest grade that earns you college credit. Here's a partially filled in frequency table for students taking these two different kinds of AP tests. Notice that any of the missing boxes could be figured out by totaling things. In the first column, if you add 39 plus 28, you could figure out that this missing box is 67. You could do that as needed for any of the other boxes. From this, you could answer various probability situations. Question B. Suppose that one of these 256,000 students is chosen at random. Using a calculator, find the probability that each student, and then there are these different questions. So question 1, what's the probability the person took the BC exam? Well, think about what you would need to know to get that. You would need to know how many total students there were. That was the 256,000. But you'd also need to know how many students took the BC exam. That would involve finding that total box. And so you would add up all the way across the rows. 28 and 10 is 38, plus 12 is 50, plus 12 more is 62. And so with that, we could get it as 62,000 out of the 256,000. Take a calculator and type that in, and you can get a decimal, because it wants a decimal to 3 decimal places. Now question 2, what's the chance a student got a 5? To figure that one out, we need to know the total number of students, which we do, 256,000, but then how many got a 5? That would involve knowing this box, the 67. And so the answer would be 67,000 out of the 256,000. Type that in to get your decimal. Now skip ahead to question 5. What is the probability a student took the BC exam or got a 5? So for the BC exam, that was this box over here, the 62. Or they could have got a 5, so we want to add on more students. We could also count these 39 students, because they got a 5. Why aren't we counting the 28? They also got a 5. They took the BC test and they are already counted within the 62. So we don't want to count these 28 students twice. So 62 plus 39 makes 91,000 out of the 256,000. Again, you could type this in the calculator to get the decimal that's asked for. So in this lesson, we looked at probability some more and looked at situations using the word and or the word or to provide criteria for the event we're interested in. We also used frequency tables that had the numbers in them that we would use to find our probabilities.